Okay, the next lesson is something called Cpctc. Cpctc, and this stands for corresponding parts of congruent triangles are congruent. And the idea is very simple. So in the beginning of the unit, we had to prove all 6 sides and angles were congruent to show that 2 triangles were congruent. Then over the last couple of work sessions, you said, you know what? All I had to do is side side side, side angle side, or angle side angle, and then I'm done. Well, the idea of Cpctc is once you've proven the triangle's congruent by the 3 sides or angles, by this rule you can say, okay, now all the remaining corresponding sides or angles are congruent. Let's do some examples. You have the worksheet. So number 1, given C is the midpoint of AD and C is the midpoint of EB, prove that angle A is congruent to angle D. The second you see the problems like this, you immediately know proving triangles congruent. In like these exercises, upcoming exercises, competition exercises, it's all about proving relationships. So if you can get the triangles congruent or similar, everything falls into place. So let's get this image in our notebook. Once again, the bow tie shows up. Let's see. Do this. And so we have A, B, C, E, D. We're told, I'm going to make a statement in reason table, and we're told that C is the midpoint of AD. We're also told that C is the midpoint of EB, and we want to prove that angle A is congruent to angle D. First thing, prove these 2 triangles congruent. Okay, what do you think? Well, because first of all, this is given. Let's see. Okay, well, if C is the midpoint of AD, that means that AC is congruent to CD. And because C is the midpoint of BE, we have BC is congruent to CE. Definition of midpoint. Okay, I'm going to be slash slash, double slash, double slash. Well, I need another side or an angle. I don't have anything about the sides, but we know. Let's be lazy. We're going to say that angle 1 is congruent to angle 2. Why? Very good. Vertical angles. Okay, do I have enough to say that those 2 triangles are congruent? Yes. I'm going to say, make sure to match it up. ACB, triangle ACB, is congruent to what? DCE. Why? Good. Side angle side. Now for the last step, because yes, it's important that I prove the triangle is congruent, but I need to prove A is congruent to D. Now, it should make sense, and it should seem intuitive. You should be like, yeah, well, the triangles are congruent, like my hand. Oh, these hands match up. Therefore, the thumbs match up. If I took these 2 triangles and matched them up, the corresponding angles and sides are congruent. Well, once again, AC is congruent to CD. BC is congruent to CE. Angle A is congruent to angle D. Why? Cpctc. Corresponding parts of congruent triangles are congruent. What else can we say? What else could I say? If asked, You could say also that, you could say that angle AB is congruent to DE. What else could you say? You could say that angle B is congruent to angle C. Going off on a little tangent here, now that I know what A is, I've proven that A is congruent to D, what else can I say? I'm not even going to write it down. Because these angles are congruent, I could now say that AB is parallel to DE. And that's the idea. We're starting from this relationship and we're building off of it. Let's look at the next question. Oh, sorry. Let's see. Given NO and PQ are congruent, and ONQ is congruent to angle PQM, prove N is congruent to OQ. Okay, let's take a look at this. Well, let's get a diagram in our notebook. That's a parallelogram. Let's see. Kind of looks like this. Kind of looks like this. A little bit lower. Good. Up. It's not the best, because I'm not the best drawer, but it's close enough. Ugh. Let's see. Sorry. So what do we have? We have N, O, Q, P. We're told that. So let's make a statement of reason. We are told that segment NO is congruent to segment PQ. I'm going to mark it up immediately. We are told that angle ONQ is congruent to what? Angle PQM. PQM. Where is PQM? PQM and ONQ. Okay, and let's see. Statement, reason. We're asked to prove that NP is congruent to OQ. Once again, the second you see questions like this, whether on tests, standardized exam, anything, or a competition, try to prove the triangle is congruent so you can get these relationships. Okay, well, this is given. I have a side and an angle. I don't know these other angles, O and P, I don't really know anything about it, but I do know I can find a third side, NQ is congruent to NQ. Why? Reflexive. Well, now I have congruent triangles, because now I have the congruent triangles. Let's see, what do we have? We have triangle ONQ is congruent to triangle along the single, along the main. Along the single, PQN. PQN. Why are these triangles congruent? Side, angle, side. Okay. But that's not what I've been asked to prove. Well, now I know that because these two triangles are congruent, all the other corresponding sides and angles are congruent. That means NP is congruent to OQ, which is what I want. And the segment NP is congruent to OQ. Why? Cpctc. Once I've proven these triangles are congruent, every other part is congruent. While we're here, what else is congruent? You could say angle O is congruent to angle P. And you could also say that, what else? Oh, this other angle in here. Let's just call them 1 and 2 because, yeah. And we can also say angle 1 is congruent to angle 2. Nice. Let's see. Number 3. Prove the altitude drawn from the vertex of an isosceles triangle bisects the base. Let's think about that for a second. Prove the altitude drawn from the vertex of the isosceles. So here's a couple of terms that I haven't really talked about, but you know what I'm talking about. Let's see. Altitude. It's a segment drawn from a vertex perpendicular to the opposite side. What's another word? How about isosceles? This is a triangle with at least 2 congruent sides. And the vertex in an isosceles is the angle between the 2 congruent sides. So the picture looks something like this. So we kind of know what an isosceles triangle looks like. We know that if we say that A, B, C is isosceles, we can claim at least AB is congruent to BC. Definition of isosceles. Right? Well, what do we talk about? Well, we talk about an altitude drawn from the vertex. So let's call that D. I'm sorry, it's a really bad picture. I apologize. We're told that D is perpendicular. It's an altitude, so it's perpendicular to the base. So angle ADB equals 90 degrees, and angle CDB is 90 degrees. Oh, you know what? I'm cutting this video shorter. Anyway, that's the idea of, I apologize, so I'm going to cut this out of the video. Anyway, that is the idea of Cpctc. Yeah, let me finish this. And you know what? Let's talk about this right now. I apologize. Anyway, we see that the altitude is perpendicular to the base. So we have angle ABD is 90, CBD is 90. Definition of perpendicular. What else? And then what else do we know? Okay, angle ADB is congruent to angle CDB. Why? All right angles are 90 degrees. All right angles are congruent. Okay, now, I didn't tell you this, but I'm telling you this now. If you have a right triangle, and you know that the height, the hypotenuse, and the leg are congruent, those triangles are congruent. And that should make sense to you, because if it's a right triangle, you have Pythagoras' theorem. That means if the 2 sides are congruent, the third side is congruent. So we would say that triangle ABD is congruent to triangle CBD because of hypotenuse, leg. I will say it again. In a right triangle, you learned about the relationship of the sides called Pythagoras' theorem, which is a squared plus b squared equals c squared. Therefore, if you have a right triangle and you have a leg and the hypotenuse, which is the long side, you can conclude that the triangles are congruent because you would have the third side congruent, and you could say the triangles are congruent because of side, 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 but you don't have to do that. We'll get to that in another lesson. I apologize. So these two right triangles are congruent because a leg and their hypotenuses are congruent. Therefore, we just proved that AD is congruent to DC, Cpctc, and therefore you can say that BD is a bisector. I apologize. Once again, the idea of Cpctc showing up again. Prove the triangle congruent, Cpctc. And that is it. Perfect. Okay.